Live! Field goal! Welcome to another episode of RockSim Live. I am Tim Van Million. I am your guinea pig and your host. I'm here to help explain to you everything you want to know about RockSim, RockSim Pro, or the Launch Visualizer. So we are live. Today is Friday, August 6th, 2022. I'm forgetting my months. We're already into August. Whoo! Yeah, thank you everybody for being here. I got a monitor over here, so I'm looking at the comments coming in. We do have the live chat going, so say hello so that we could recognize you, and also say where you're from. And if you have a RockSim question or a rocketry question, go ahead and ask that, and I will try to answer that for you. So we already have Robert Monday here, and Rosa from Ottawa, Vernon Gortz says hello. And there's other people in the room, but they haven't chimed in yet. So let's get started. I don't have any agenda, so I am waiting for your questions. What's your burning question that you have about RockSim? It doesn't have to be that's kind of a pun intended question. It's a statement. Rocket motors are burning. Fortunately, not burning in the office today. Yeah, so go ahead and put in your questions. That's what I'm here for. I'm here for you to answer your questions. So I'll go ahead while that's coming in. We have Julie from Indiana and 10-minute vacations from Utah. Let me show you my screen, and I will give you like a little synopsis if you have never done RockSim before. So what we're looking at is the Apogee website. ApogeeRockets.com is our website. And when you come to our home page, there's this scrolling banner bar here that has a newsletter sign up. This has a little ad for RockSim.com, which is the launch visualizer. And then there's the Maker's Dozen, which is, I think I have the Maker's Dozen poster behind me. I don't know how that was a coincidence. And then we have an ad for RockSim. So if you click on this, it will take you where you can get information about RockSim. RockSim 10 is available. We released version 10 in 2020. We've had a number of upgrades, free upgrades since then. So we're on, I'm not sure exactly which version we are on. If I go to RockSim, I can go to the About RockSim, and the one I'm running is 10.4 F2. And I think there might be some newer versions since then, but I just haven't installed them yet on my computer. Most of them have to do with installation issues. So I'm already installed, so I didn't see the need to have to go through another upgrade. But I'm going to be upgrading soon because we're working on more fixes. Yeah, Microsoft and Apple keep doing us in whenever they release a new OS, and Apple is working on a new one again. They released a beta version, and we have not tested it on that. We know that they are releasing it soon, so eventually we will have to test it. But I think we're going to be okay because we've been doing a lot of stuff for the latest version. Was it Monterey? They did Big Sur and then Monterey. I think that's what they're on right now. I'm still on Catalina myself, but we're here to talk RockSim. So you can get a free trial version here. If you're ready to buy, click there. If you have an older version, like version 8 or older, you can click here. There's a version 9. There's a free upgrade if you had version 9 that you can do here. Be sure to read the system requirements before you do an upgrade from version 9, because some older computers, if you're running version 9, you're probably running on an older computer, Like I said, because Microsoft and Apple keep upgrading the operating system, we keep having to make changes in RockSim. And now what's happening is there's a new upgrade, and the older operating systems are starting to drop off. Yeah, so be sure to read the, and I'll show you where to get that. You go to How To and Guides, System Requirements. Go to How To and Guides, the menu, then come down here to Software, and then come down here to System Requirements. And that will tell you which ones that you can be running. So on Macintosh, you can run 10.15, which is the Catalina version. That's what I'm running. That works, but anything older than that, so 10.14, not probably going to be working anymore when we do these upgrades. Also, if you go to How To and Guides, come down here again to Software. Over here on this side are tutorials. We are doing tutorials today, so any pertinent questions you can ask today and I'll get to those. We're doing the RockSim live training right here, but other tutorials are here. If you go to live training, these are the archives of our previous episodes. We are on episode number 81 right now. Once it's done, probably early next week, we'll post the link to YouTube, and then we'll have all the topics that we talk about along with the time stamps of those topics in the YouTube video, so you can just scrub through the YouTube video, find that particular time, and then you'll find about how to add them in RockSim. Okay, so that's kind of the basics that I go through every week. So let me see if we got questions. Robert Monday says, forgive me if this has been covered, but how do I change total weight? I have a Cherokee E I just built and it comes in at 109 grams. Okay, we can answer that one, Robert. Stan Anderson says, hello from Orlando. I was president of the Rocketry Club in high school from 1970 to 1974. Wow. I was 5 years old in 1970. So that puts Stan a little bit older than me. I'm glad you're here, Stan. Just because you're older than me, that doesn't mean I can't make fun of you. Just joking, Stan. You can put your jokes in there too, Stan. I can take it. Those young whippersnappers, they don't know anything. Okay, so what are we doing? We're doing how do I change the weight of a Cherokee E. So we don't sell a Cherokee E. So let me see if I can find a RockSim file for one. Cherokee E RockSim file. So I'm going to the internet. So here at rocketreviews.com is a Cherokee E RockSim design file. So let's go take a look at that. So that kind of looks like a Cherokee. Ooh, that's kind of cute, that little like midget Cherokee. Okay, download Cherokee E Rocket. That's anything that ends in the extension RKT is a RockSim file. So I'm going to download that, and you can see it's in my downloads folder. If I open my downloads folder, right there is the Cherokee E, and then to load it into RockSim, here's RockSim. I just find it and just drag it onto RockSim, and there it is. There's the Cherokee E. Now Robert's question, he says his weighs 109 grams. So I'm looking at the rocket right down here is the mass 62.25 grams. So Robert, here's the easy way to do it. There's actually there's multiple ways of doing it. The easiest way is come up here to mass override at the top of the screen. Just click on that tab, and right here it there's a little checkbox that says use the values shown below for all the simulations. And you'll notice that the units here are grams. So you can come right here and put in 109 grams. But when you do that, you also need to put in the center of gravity location. Now the center of gravity, let me go here. As you know, when you balance a rocket, where it balances is the center of gravity. So you need to know the position of the center of gravity from the tip of the nose cone to where it balances, right there. And then once you have that number, then you go into RockSim and you put that number right here for the sustainer. So I don't know where your Cherokee E balances. Right now, at 62.25 grams, it balances right here, which is, if I go over here, it's at 17.5597. So I'm just going to put that in this because that's kind of like the best guess that I have. 17.5597 inches from the tip of the nose cone. So when I check this box, you'll see the weight will change, but the center of gravity is not going to change. So the position of the center of gravity is not going to change because I've specified it at that location. So when you do this, do it without the rocket motor in the back end. So because when we put the rocket motor into RockSim, it's going to put weight in the back, and so it's going to move the center of gravity back. So, so when you're doing the mass override, like I said, do it without the engine installed. So if there's an engine in the back and it's showing up, and you'd probably notice it, then go up here to prepare for launch, and then you'll see the little box that says clear or clear all. If you check on those, it will pull the engine out of the rocket. So, okay, so I'm going to check this box right here, and we'll see what happens. Bam! Oops, what happened here? Because it shifted the CG all the way at the tip of the nose right here, which is behind my head on the screen. Can't see it, but there it is. I don't think I hit the tab key over here. So yeah, you got to hit that tab key so it takes that number. And so then I put it back to where it should be. So that's the easiest way, okay? Another easy way to do it that I think I might prefer if I was doing it myself. I would use, okay, so I'm going to uncheck this. And so I'm back to where I started. So I'm 62.25 grams. So what you can do is add a mass object into the rocket to account for the extra weight. So what is the extra weight? So let me get a calculator here. So you said 109 grams. So I'm going to take 109 grams minus this number right here, 62.25. 62.25 equals 46.75 grams. So I'm going to create a mass object, and I'm going to put it in the rocket at 46.75 grams. So to do that, you can come to Design Components. First you have to decide where you want to put it in the rocket, and I think I want to put it in this tube, so I'm just going to click on the tube. There's another tube down here, but I'm going to click on this tube, and it highlights it up here. So once this is highlighted like this, then I can add that mass object. So I click on that, and what it does first is to bring up the database of all the mass objects that it has in the database, but we don't really care about that. So we're going to cancel out of the database, and then we're going to be right here. So it was 46.75 grams, and then we need to specify a location. Right now it's at 0 inches from the front of the owning part. And remember, the owning part was this body tube right here. So it put it right there. There's my new mass object. But notice what that does. It moves the center of gravity which used to be way back here, all the way up to here. So now what you do is you slide this mass object around using the slider bar until your center of gravity is in the right location. And again, do this without an engine installed in the back. And I don't remember what we had before, but I think it was somewhere around 17 something inches. So I'll just leave it right there and click OK. And now look right here, our mass is 109 grams. We have that extra mass right here, which is right here. And I might change the name of this mass. So I just double clicked on it to open the screen. And what I'm going to do is I'm going to change the name to paint mass because you never know what the paint mass is. That's a lot of paint, 46 grams. Paint and other unassigned mass. Okay, you know, it could be little bits of something. Maybe you have clay in the nose, or who knows, extra epoxy somewhere. So that is how I would quickly change the mass of the rocket. Now, if you wanted to be really, really accurate, what you do is now you got your rocket built, and you take each component and you weigh it. And then instead of doing one mass for every one mass for the entire rocket, you go and adjust the weight of each component. That's a little bit harder and a lot more work because look at all the components we have. So you'd have to weigh every one of these, and you also need to get the center of gravity of each of the components. So you have to balance it on your finger and then measure from the tip or the front of that part to where it balances. So like on the nose cone, if I open that up, I can come here to mass override on the nose cone, and it says use the mass and CG information below. This one I was already using the mass override on. So I had put the center of gravity at just under 3 inches from the tip. So that's like really far forward on this nose cone. Well, that's this nose cone here in the Cherokee E. But if I was in real life, right? So you would do that for every component. And the reason you might want to do that is it makes the trajectory a little bit more accurate. You probably might not notice it, but if you are really picky, you might want to do it that way. Because what it does is it changes what's called the moment of inertia. The moment of inertia is a property of the rocket that tells you how resistant it is to rotation. And the higher the moment of inertia, the more it doesn't want to rotate. And so when it's flying, it doesn't want to rotate as much. And so we want to match that with an actual number, and Roxim will calculate it automatically, but it needs to know the distribution of mass along the entire length of the rocket. But if you just want to do the quick and dirty, like I said, just do the mass override or just put a mass into the rocket. The important part, and as I was getting at, is making sure that center of gravity is in the right spot. Your moment of inertia might be a little bit off, but it won't be too bad as long as your center of gravity matches the real rocket. Okay, so hopefully that answered your question, Robert. If it doesn't, please ping me again and we'll go again. Julie Kaufman says, my PC desktop died and not sure how to get RockSim to reload. Can I get it from Apogee? And the answer, Julie, is yes. Let me go to the Apogee website again. ApogeeRockets.com. So what you can do, Julie, is you can either download the free trial, or you can download RockSim from the link that we gave you when you bought it originally. Both of them are the exact same version of RockSim. So if you don't have the email with the original link, don't worry. Just go to How-To and Guides, come down to Software, and RockSim free trial, and you'll load. You'll give it. You'll enter your name in the email. You'll select Windows or Mac. I think you said your PC, so I assume it's a Windows. And then hit send now, and what will happen is we'll send you a new link to download it. So then download it, but then you still have to activate it. And to activate it, Julie, what you do is, again, you go to the Apogee website, and then you have to log in to your account. So if you've purchased from Apogee Components, you'll typically have an account. So up here at the top, you can create an account or log in. If you already have RockSim, you probably have an account, unless it's been like a really long time. So you'll come here to log in, and if you can't remember your password, there's down here you can enter your password, and then you'll sign in, and then once you sign in, you can come here to the account menu. And the account menu is going to change. I'm not logged in, but once you're logged in, this My Account menu will have, there'll be a menu that says RockSim. And then you can click on that, and it will give you your unlock code for your RockSim. And it will tell you how many times that unlock code has been used. And you're allowed up to 3 installations. So as long as you've only installed it on one computer, you got 2 left. So you can still install it on your new computer after you have erased the hard drive and everything. If you've already installed it on 3 computers, what you do then is come here to Shop, and then come down here to Rocket Software, and then come over here to RockSim, and then, Rocket Software, I need to go to Upgrades. RockSim Upgrades, click on that, and you'll see RockSim License Key Regeneration Fee, and it's $1. And the reason we charge $1 is so that you don't slip through the cracks. And so what that will tell us is that, hey, you've installed it on 3 computers already, and you need us to wipe off those old computers so that you can install it again on your new computer. So go ahead and do that, and then we can get you going again. So the easiest way is download the trial, log into your account, find your keys, and then just reinitialize that new computer. But if you need to get a new key, come over here to License Key Regeneration. Okay, hopefully that answers your question, Julie. If not, you can come here to the Apogee website. We have a phone number right here, and we do answer the phone live. So during business hours, we should always be answering the phone, except, of course, when we have staff meetings. Then everybody's busy, and then you'll get a message. But normally, just call the number. You can also use the contact form, and you can send us a message saying, I need help. I got a new computer, or my old computer died, and I need my license keys, and we can help you out that way. But that only happens during the week. If you're on the weekend or a holiday, you're gonna have to wait until the following workday. We don't have any new holidays coming up until in September. The first Monday in September in the United States is called Labor Day, and that's a scheduled holiday for Apogee. But between now and then, we're here. Okay, Vernon says, what is the best way to find the recommended motors for cluster rockets like the Flamethrower? Really good question. All right, Vernon, let's go to that one. Let me go back to RockSim. Let me take a look at this one in 3D, what it looks like. See if whoever made it. They made it a white and blue rocket. That's kind of a pretty rocket. Okay, so let's go to the Apogee Flamethrower. So I'm going to File, Open up here at the top. And I want to go Flame. Man, all of a sudden my computer's slowing down. Flamethrower. And I am looking for a flamethrower rocket. I'll open that. Do I want to save that one? No. Okay, so here's the Apogee Flamethrower. Let me get it in 3D. Oh, this version is ugly looking. It's not yellow. It's olive drab and blue. So this one has a 2-engine cluster in the back. And so he's wondering, how do you do recommended motors? Typically, what RockSim version 10 did when we upgraded version from 9 to 10, we added a really cool feature called recommend motors. To use it, you just come up here to the top, to the prepare for launch button, click on that, and right down here there's a button called recommend motors. But you can see right now it's grayed out. You know, like these are active buttons, this one's grayed out because it's really normally what it does when you click on it, it will run a simulation for every rocket motor that will fit that engine mount. So yesterday we did we did a rocket that had a 24 millimeter engine mount. How many rocket motors do you think, how many different rocket motors, just not the delays, not different delays, but how many, individual rocket motors do you think are available in 24 millimeter? If you want a hint, go to the Apogee website, go to Shop, come down to Rocket Motors, go to 24 millimeter rocket motors, and you'll see displaying, 1 of 10 of 68. There are 68 different 24 millimeter motors. Now, some of these are bulk packs. So of the 68, when we ran it yesterday, there was 53 different rocket motors that are 24 millimeters in diameter. So that's just for one engine mount. Now, when you got 2 engine mounts, how many different combinations of rocket motors can fit that? And I think the answer is you double it. But when you get to 3 motors, now you got a problem, because now it's important on which motor is in which tube. So here, looking at the back of the rocket, I got 2 engine mounts. And I could put a D12 in one of them and a C11 in the other one. Or I could put a D12 in this one and a C11 in that one. So now instead of being 53, you were at 106, but I think that we just doubled it again to 212. So the combinations just go astronomical really fast with the number of motors and the number of engine tubes. So if you had a 3-engine mount, the combination of where motors can go in those is just too crazy. So we made a decision to only allow the recommended motors to be used on rockets that have a single engine mount in them. And that includes single stage rockets. So it won't work on multiple stage rockets. if you have a multiple stage rocket and you want to check engines, basically what you have to do is you have to take your RockSim file and delete completely the lower stages. So you only have the upper stage. And so you can run simulations, recommended motors on the upper stage, but not the lower stage. But if you have a 2-engine cluster, that's not going to work. So how would we do this? And the answer is it's just brute force. This one has 24mm motor mount. So I have to just kind of start with a guess. So basically what I would recommend, who asked this question? Vernon. What I would recommend, Vernon, is to go look at the list of rocket motors, like on the Apogee website, and then find out, go through your range box and see what motors you already have in there. And then you might want to say, well, I like a white lightning motor. So here's an E18W, and the W stands for white. It has a white propellant. The T stands for blue thunder, so this one has a blue flame. The J is for black max or black jack. So that has a smoky flame. So you can kind of start with what you prefer. So say, for example, I like that white. So I could say E18W. So then I would come back into RockSim and I would go, selecting a motor. So choose engine. And instead of, I'm going to change my diameter filter from show all engines to show only that match the motor mount diameter. And it's showing me what the motor mount diameter is here, 24mm. And then under manufacturer filter, I'm going to show just the Aerotech motors. And then I'm going to go look for that E18W. And there's also an E20W right here. So I could pick either one. They're both pretty close. One might be a reload. Let me check. The E18W is a reload. So if you wanted single use, you'd have to look in this column right here for single use. See where it says single use, like here under Quest. Let me sort these. So to sort this list, just click on the column. Okay, so now they're sorted from smallest motor to highest motor, so then I can go down here to the E's. I'm just scrolling down. So there's that E18, and here's the E20. So the E20 is a single use, where the E18 is a reload, because this is the nomenclature for the Aerotech reload. It's a 24mm diameter case, but it's 40 Newton seconds of total power that will hold. That basically, if you see that configuration, 24-40 or 24-60, it's a reload case. Under Cicerone will say 1 grain, 2 grain. See right here, this is 3 grain. So that tells me that's a reload also. But single use, if you prefer single use, so in this particular case, I might prefer a single use motor. So under type filter, I can say single use. And there's that E20. So now my choices have gone from 53 down to 1, 2, 3, 4, 5, 6. So now I can say, okay, let's load an E20. I always pick the longest delay available for the delay. Click OK. And so now one motor is loaded, and then I need to load the other one. And so now you have a choice. Do you want another E20? Probably you do, because you don't want to have unbalanced thrust. So I'm going to load that other motor really quick, what you do is you just click down here, the load all button. That load all button will load that motor that you highlighted into all the motor tubes that are also the same diameter. So if there was an 18mm tube along with these two 24s, it's only going to load in the 24s. It's not going to load that particular E20 into an 18 because it doesn't fit. So I'm going to hit load all, and then it loads it. And then you're just ready to run your simulation. So I'm going to hit flight profile. Let me check my launch conditions here, just to make sure that, so I got an 8-mile-an-hour wind, and I got a 36-inch launch rod launching straight up. And then hit the flight profile, and it will run the simulation. And you can see it's gone pretty high. It went well over 1,000 feet, 1,710 feet. And now it's loading the 2D flight profile. And here's my rocket sitting down here. And we can see an animation of the flight. And click on play. You can see the rocket's taking off and it's going up. It's arcing over a little bit, but not too much. It's still within our weathercocking cone. We want the rocket, its peak altitude point, in the middle of this cone somewhere. We call this cone right here the weathercocking cone. And as long as the peak point is inside the cone, that's a good sign. That's a really good sign. And so now the parachute is out and it's coming down, and I'm just going to bring it down all the way to the ground, and it drifted 1,003 feet. That was a pretty good flight. So that particular combination, 2 E20s, is a good flight. And then you come here to RockSim and it says, okay, make it 7.61 delay. So now when you go to buy your motors, I'm looking for an E20 dash, or somewhere around a 7. So come back here to the chart at the Apogee website, come down or go back up to the E20. And the E20, I got two choices. I got an E20-4 or an E20-7. So I would pick that one. And then, okay, so that one works. And now you're going to say, okay, what's the next one? So then I would go and do it again. This time I'm going to, choose an engine. I'm going to still stick with the single-use motors. Oops, single-use. And maybe I wanted the E30. This has the blue flame, or there's the black flame. And here's some higher thrust ones. So let me choose the E30-10. It just chose a -10 because there was an E30-10 as well as that E20-10. So we have an E30 in one and an E20 in the other, and I'm gonna load that one into both motors. So now they're both loaded, and click launch. And this time I'm not running a flight profile. I'm just running just the simulation because I know it's going pretty good. And it went a little higher, 1,900 feet versus 1,710. And this time it recommended the 8-second delay. So if I was on E30, I would come down here, and again, I only have a choice between an E30-7 or an E30-4. And again, I'd probably choose the E30-7. So what's going to happen is it's going to be deploying on the way up because the delay, it wants an 8-second delay. So I would rerun that simulation, prepare for launch. Now this time choose the 7-second delay. Come on. 7-second delay. Load all. Now they're both 7 seconds. And this time I'm going to look at the flight profile because I want to see, how fast the rocket, this one is going to be deploying on the way up. I want to see how fast it looks like it's deploying when that parachute comes out. So the rocket takes off, it's going up, and it's slowing down, but it's still moving pretty good. Okay, now it's kind of, okay, so you see it still had some upward velocity when that parachute came out. And so that's concerning. So we want to check one more thing there, and that's the speed at deployment. And there's a column in RockSim where you can look at that velocity at deployment, miles per hour, We're at 31.85. So it was still moving upwards at 31.85 miles per hour when the parachute came out. So now you have a question, is can my parachute handle being deployed at 31.85 miles per hour? And that's a good question. We like to be under 50 miles per hour. So we're under 50 miles per hour here. But if you're using a plastic parachute versus a nylon parachute, nylon parachutes are much more durable than a plastic one. So if you're using a plastic one, you might want to say, well, is that delay, is my parachute going to be coming out a little bit too fast? And if it is, you might want to not use that motor. So this is where it takes a little bit of human consideration. You know, this is engineering. This is exactly what engineers do. They're looking at those numbers and saying, will my rocket be okay with it deploying at 31.85 miles per hour? It's probably going to be okay, but if you're unsure, either, you know, swap out your parachute, put a stronger parachute in, reinforce your plastic parachute somehow, and there's ways of reinforcing plastic parachutes to make them stronger. If you need help with that, we have videos on the Apogee website. We cover all of that stuff. Or choose a different motor. But again, the process of picking motors with clusters is a lot more complicated, and it's very much a brute force operation. Sorry, I know we're all looking for the shortcut. That was a really good question. Okay. Julie Kaufman says, I purchased it, but I can't find my info. So hopefully Julie, yep, she got the steps. Andrew says, this is awesome. Thank you, Andrew. We appreciate that. Make sure you hit that thumbs up on the YouTube video, and then, you know, ring the bell and subscribe. Aaron Regan says, what is your smallest parachute? Okay, I can answer that. So if you go to the Apogee website, scroll all the way to the top, and if you're on a long page, which most of the Apogee ones are, because we put a lot of information in there, click that little arrow, that up arrow down in the corner, which was underneath my head, and then go to shop, come down here to building supplies, come across and down to the parachute menu right here, click OK, and you will see this chart right here lists all the parachutes, and they're listed in order from smallest to largest. So the smallest we have is a 12-inch, and we have several different versions of 12-inch. We have a nylon parachute, a multicolored plastic parachute, a competition mylar parachute, which is kind of silver like that. And then we have a cut to size parachute, which means you start out with a big one and you can cut them smaller. Yeah, so if I click on that nylon parachute, you can see what it looks like. That's 12 inches across. You know, you can see how small it is when you put it in a tube. Kind of, you know, get a size perspective with a hand right there. Okay, so that's the smallest parachute that we have. Rick DeFossa says, New Hampshire, checking in. Thank you, Rick, for showing up. Stan Anderson says, Fave rocket back 52 years ago were the Estes Big Bertha and the Estes Birdie. We tested everything, small engines and big rockets and big engines and small rockets. Altitude and speed were all analyzed and charted. That is cool, Stan. We still sell the Big Bertha if you want to relive your glory days. You just come to the Apogee website and type in Big Bertha in the search bar, and it will find it. And then you can click on it, and you know, this is where you can order it. And yeah, like I said, this is the rocket he was talking about if you're unfamiliar with the Big Bertha. Now the Birdie we don't have anymore, and I don't even remember what that one looks like. Anyway, Julie says, got Roxim reloaded, and thanks. So she's already up to speed. Great, Julie. See how fast that is? Rick DeFossis did the math. He says, with 53 unique motors, one mount equals 53 choices, two mounts equals 1,431 combinations. If you have 3 engine mounts, you got 26,235 combinations. Thank you, Rick. I knew it's is it one of those factorial things that that's in? Oh, look, he did he put the equation in there. R factorial times n minus r factorial, where n equals the number of motor mounts and n equals the number of motors and r equals the number of mounts. I have to bookmark this page because I've been always looking for that formula, because this question comes up a lot. Oh man, that's a lot. That is a lot. Just imagine like something like the Lock Ultimate. Let me just do Ultimate. This rocket right here has, it's a 7-engine cluster. So look back here, you know, you got 7 engines. Imagine. I don't even, that's got to be, Rick, do the math for me. Tell me how many combinations that might be. If they were all just 24 millimeter, but these are 29, and there's well over 129 millimeters. Let me go back up here to shop, rocket motors, 29 millimeter motors, 157. Do the math. Thank you, Rick. Johan is from the Netherlands. He says, with clustering, also unexpected and before impossible possibilities that can happen. Motors ignited and ejected from the side if they don't go off. Yeah, so what happens if one of your motors doesn't ignite? So now you have a 6-motor cluster, but you have the weight of the 7th motor in there, so you have to account for it. It's just, the possibilities are just phenomenal. Andrew says, what's going on with factorials? Andrew, we're trying to figure out possible motor combinations when you have a cluster. So, yeah. Johan says, Rocket Friend is building a 75 millimeter Patriot ATM with 50 millimeter engine tube for clustering. Cool. Building it in 2 days. Yeah, that's a good project. Johan says, yeah, I'm building 7-engine cluster inspired by the Ultimate. And then Johan also says, I say only 4 combinations on 7 tubes. Okay, Rick did the math. He did. What it comes out to, with a 7-engine cluster, 1.17 billion combinations. Well, so I think that would probably take Roxim, if it was possible, it would probably take a couple of years for it to run all of them. And that would be a good one for a quantum computer. It could probably whip them out like that, but we don't have quantum computers yet. Art Applewhite from Texas says, howdy. Cool. Art, we're going to be in Texas next summer for the World Space Modeling Championships. So I'm sure you will be there. That's all the questions I got. We still got like 10 minutes left in this, so if you got a question, you can still ask it. Gotta get a sip. Johan says, I wish your friend luck and success. 7 engines is serious. What's the terminal velocity with that? Well, terminal velocity is usually with the rocket coming downwards. Going up, there is no terminal velocity. You're just limited by drag and thrust. You just have to whatever you can push. Okay, I'm waiting for questions. Bring them on. What we can do, what would be fun, let's do an asymmetric thrust design and see what happens. So I am going to open RockSim Launch Visualizer. So the launch visualizer is at rocksim.com. And I'll wait for that and check here. I saw my screen move over here. All right, so this is the launch visualizer, rocksim.com. You just log in. And I'm going to log in. And I'm going to choose, I can see if I can find a cluster in my designs. I got a 3-stage. I got the flying machine. That's a cluster, so let's select that. Okay, so it loaded it, and then you're going to see a picture of it here when it loads it on the pad. And this one has 2 side pods plus a motor in the middle. So let's load this, but let's do an asymmetric thrust and see what happens. So I'm going to come down here to select motor, and you can see our 3 motors. One of them is 24 millimeter and 2 of them are 18, and you can tell that the location of this center motor, because the red dot shows it's in the middle of the rocket, and these on the 18 millimeter, they're on the outside, so they're in the pods. But I don't know which pod is which until I fly it. But that's okay. So first we're going to choose a 24 millimeter motor. Let's put in an Estes, like a D12. So I'm going down to the Estes motors. Here's a D12. Select the delay. I'll choose a 7-second delay. Click OK. So that one is loaded, and then the outer tubes, select it. You can double click on it and we'll bring up the engine selections. So let's put in a low thrust motor in one of the rockets and a high thrust in another. So for the low thrust, let's put in, what do we got available? We got an Aerotech D 2.3. Now this is a reload, and reloads are plugged, so we'll leave the ejection delay. Well, we want it to fall off, so I'm going to give it a custom delay of 0 seconds. So when the motor burns out, that pod that's on the side can fall off. Okay, and click OK on that one, and then on this side we'll put a high thrust motor. So now we're looking for something that's really high thrust, and here's a D24. So you're asking, how do I know which is high thrust and which is low thrust? The number after the letter is the thrust of the motor, the average thrust of the motor measured in newtons. So newtons is a measure of force, and so the higher the number, the higher the average thrust. So you got a high thrust versus low thrust, and I'm just looking at the numbers, which number's higher or which is lower. So a 24 is a lot greater than 2.3. In fact, it's more than 10 times as great. So this is a high thrust motor. And this one, I'll also do a custom delay and make it 0 seconds. And click OK. So now we have rocket motors loaded. So we have to select our launch location. So now I'm just going down these tabs here, and we'll go through it real quick. Choose a launch site. Okay, I'm going to just choose one at random. I'll just choose that one. And what it's going to do is it's going to load that launch site right here so we can kind of get a lay of the land, you know, what our launch site looks like. And there it is. I'm in a parking lot of something. So I'm going to move the launch pad a little bit. So this is an interactive 3D environment right here. And north is the black arrow. So north, I'm going to just swing it around. So north is pointing up. And then it looks like I got some nice launch pad area over here. So I'm going to put my launch pad right there. So I'm just double clicking on it and that puts the pad right there. And then you have to confirm it. So I'm going to confirm that launch site right there. And when it confirms it, it brings over all the parameters of the launch site, its latitude and longitude and altitude above sea level right over here. So I got, looking at this thing, I got some good launch area to the north, good launch area to the south. So I can aim either of those directions, but I probably won't go to the northeast. So I need to know that because now I'm going to change the starting location. So I'm going to aim it, you know, 13 degrees, and let's aim it to the south. So I'm just grabbing the arrow and sliding it around. So now I'm going mostly to the south, and you can see my rocket on the pad. You know, it's, if I look down straight from up above, it's aimed mostly to the south, which is good. Okay, so let's check the wind. We have a steady wind, and the wind velocity is about almost 5 miles an hour coming out of the west. You can see the direction of the wind and click OK. And then we need to launch. We already loaded the motors under flight events. Oh, let's check that. The parachute that's in the middle of the rocket, we're going to eject that at maximum ejection delay, and that was a D12-7, so that's 7 seconds after the motor burns out, the parachute will come out. These pods, they have parachutes in them, and they will also pop out at the maximum ejection delay. I don't know if you can see my screen here. I need to make it a little bit smaller so you can see it. Okay, so my launch button is underneath my head. It's right here. So when I'm ready to launch, I just click launch. And it's going to ask me to simulate, and it's going to use up that many credits. I'm going to say OK, simulate. And it's running the simulation in the cloud, which means it's on our servers somewhere in the world. And then it's going to load the rocket on the pad, and we should see our launch site in the background. It's kind of slow loading. Okay, so now we're getting there. Now it's loading in the grass. So kind of getting the lay of the land here. We put it in the middle of the field, but north is kind of down and towards the right. So I'm going to swing it around, put north back up to the north so you're kind of oriented. You just grab this little compass wheel and spin it around. And this is fully 3D, so I can, you know, if I tilt it, you know, now I'm looking off into the distance. Now I'm looking, you know, more down on it from above. All right, so then to launch it, we just click this launch button over here to play the animation. And we'll see the rocket take off. And it looks like it's going mostly straight, even with off-axis thrust. The rocket's arcing over. And the parachute has now popped out. All right, so let's see that again. I'm going to stop it, go back to the beginning, and I want to turn on some things over here under Preferences. I want to remember my camera view. I want to see the trajectory path, and I want to extrude the path to the ground so I can see the ground track. And we'll turn off the flame and smoke, just because, or the smoke, so that we can see parts falling off the rocket. Because these are pods that are on the side of the rocket. So let's launch it again, and now you can see this green line is the trajectory path going upwards. Okay, I'm going to pause it right there, and let's take a look. Let's zoom in on it. So there's my rocket, and if I look at it, one of the pods is still attached, and if I swing it around, can I see the other side? One pod fell off, the other one is still attached. Is that D3 still burning? I think it might be. Something is still burning on the back end of the rocket. So that must be that D3. Okay, so at that point, the parachute popped out because the rocket reoriented itself. I lost the rocket. I had to zoom out to find the rocket. I'm looking at the ground. There's the ground track of the rocket. The launch pad was way over here. There's something landed right here. That was probably the first pod. The first pod fell off and then landed over here. Yeah, that's a pod. So that green line here is the trajectory of the pod. It fell off the rocket right here when it was that point in the sky. And then the other one has now fallen off. So we should see a pod somewhere in the sky. And it's right there. That little line right there is actually the pod. Oops, I zoomed out too far. Oh, okay. So that pod is falling off. Yeah, there's the pod. It's really jumpy. You can see that pod falling down. Okay. So that's how you run clusters and see if off-axis thrust is going to affect the flight. I would use RockSim Pro or the Launch Visualizer. It really helps to see things when you're in a cluster. Oh man, we got a lot more comments now. Where did I leave off? Stan Anderson says, Johan de Sloper, wow. In feet, that's 2,300, wow. Andrew says, can the rockets be customized for control and nav? I've watched a video by BPS, and he landed his rocket. Andrew, the quick answer is like you saw in the BPS video, it's really difficult. RockSim cannot do that. It cannot simulate a simulated landing like that because we don't have control of the rocket in RockSim. In RockSim, everything is, once it leaves the pad, there's no control on it. The only control you have is selecting the delays or using electronics to pop out parachutes. Johan says, if you put 24 millimeter by 95 tube in the middle, can you get H motor equivalent? And the answer, Johan, is yes. If you cluster enough motors together, you can get any amount of power that you want. So you can get an H motor, you can get an I motor. It just takes a lot of motors. You got to light them all, though. Stan Anderson says, Andrew, Formula One race car teams use FlowViz paint to see how the aerodynamics are working. I imagine it would work with rockets. Stan, you're right, it would work. Art Applewhite says, the rocket will zigzag a little because the thrust is greater on one side, but for less time. Yes, so it's typically because of that D24. It probably kicked it off to the side for just a split second, but then it burned out. But then on the other side you have the low thrust motor, and eventually it will straighten it out. And I think that's why that rocket flew pretty straight. FlowViz paint doesn't argue with what it's painted on. That's correct. Rockets are actually faster than F1 cars. Yes, with model rockets you can exceed the speed of sound. It's probably one of the very few hobbies that's affordable where you can do that. Johan says the D3 is about a 5-second burn. Yeah, it's a long burn motor. Art says, let's hope you haven't started a fire in the San Juan National Forest. You can see on the map right here, it says the San Juan National Forest. So yeah, we don't want to do that. Well, anyway, we had a great episode today, and I want to thank you for all the great questions. This was a fun one. I enjoyed today a lot. But we are sadly out of time, so you'll have to come back again next Friday. Have your questions ready. We will try to answer as many as we can. This is your show where you pick the topics. So until next week, go out and fly some rockets. So we're going to launch or end in 5, 4, 3, 2, 1, launch.